Hello guys, in this episode I am going to be talking about acids, bases and uh, and salts. You get to learn this topic in class 10 science textbook in chapter number 2, acids, bases and salts. They are they are all compounds, but when acids and bases react together, it gives off salts. So we have a lot of different properties based on which we can determine whether the given compound is acid or base, depending upon their uh, their chemical nature. So first of all, let's understand the chemical properties of acids and bases. Acids and bases, their chemical properties we can determine by the following test, such as number one is the red litmus solution, blue litmus solution, the litmus test, these two. Next is the phenolphthalein solution test and methyl orange solution test. Based on their coloration, this is this test is determined based on the observations on the observable color change, and that's not the only case. The next test is uh, the odor test, the smell test. The smell test, we call it odor test or olfactory test. Okay, we've got this jumbling problem. Okay, so we were here, the test, the coloration test, such as this litmus test and phenolphthalein solution test and methyl orange test. Now, how do we do this test? When we dip this red litmus uh, into into a base solution, the base. Okay, understanding the chemical properties of acids and bases. Acids, when the blue litmus is dipped in the acidic solution, it turns red. The blue litmus turns red in acidic solution, and in basic solution, the red litmus will turn into a blue color. The red litmus turns blue in basic solution. Now let us learn how do acids and bases react with metals. Metals, the alkali metals, those most of the elements that are situated in the left hand side of the periodic table, they are called as metals. So when metals react with acids and bases, let's learn about that. Now in this diagram, it is given about the uh, the metal reacts with sulfuric acid. So this zinc, the given metal is zinc. This zinc reacts with sulfuric acid to form the zinc sulfate, which is a salt, and gives off hydrogen gas. This hydrogen gas, the formation of this hydrogen gas, we can determine by channeling it through this delivery tube and through this solution, soapy solution. And when you held this a lighted candle above it, then we see the popping sound and the flash burn in the normal candle. Not only that, we can simply identify the oxygen gas release through the bubble formation in the solution, in the soapy solution. Okay, what's that? Where do we go? Okay, there's just glitches going on. Okay, we were still with the indicators. Now, how do bases and acids react with metals? Okay, this we have discussed. Now, the previous mentioned reaction can be written in this way: acid, when reacts with metal, it gives off the salt and hydrogen gas. Now, acids, in our case, it was the sulfuric acid, and metal it was zinc, and the salt it was zinc sulfate, and it results in the formation of hydrogen gas. Now let's learn about the bases. When the bases reacts with metal, this hydrogen sodium hydroxide, this is base, and zinc is metal. So when this base reacts with metal, it gives off the sodium zincate, which is also a salt, and gives off the hydrogen gas. So the reaction of acids and bases with metals, it's basically the same thing. It's almost the same thing. It both results in the formation of hydrogen gas. How do metal carbonates and metal hydrogen carbonates react with acids? Now, metal carbonates and metal hydrogen carbonates, they react with acids in the same way. Metal carbonates such as this following equations. Metal carbonates such as sodium carbonate and sodium hydrogen carbonate. So this they react in pretty much the same way. They react with the acid to form salt and water by releasing the carbon dioxide gas. So in both cases, it's the same thing. Metal carbonates, metal hydrogen carbonates, they react with acids to form metal. In this case, is the sodium chloride, the salt, both salt and water, and carbon dioxide gas. Now we will move on to the metal. Okay, the metal carbonate, metal hydrogen carbonate reaction with acids, it gives off salt, hydrogen, carbon dioxide, and water. So this is the equation, the written equation for the reaction. Now the next topic is, how do acids and bases react with each other? How do acids and bases react with each other? Now, acids and bases, when they are mixed together, when they are poured, then what happens? Let's see. Acids and bases, when reacts together, they form salts and water, but no any gas, just salt and water. Such as this sodium hydroxide, when reacts with hydrochloric acid, it gives off sodium chloride and water. So in very short way, we can simply write such as this: base and acid to give salt and water. Reaction of metallic oxides with acids. Metallic oxides, when reacts with acid, it gives off salt and water. So we can conclude that metal oxide and acid reacts together to form the salt and water. So the metal oxides is basic in nature, because in this equation, it's like basically metal oxide replaces the base. So the result is almost the same thing. When acid and bases reacts together, it gives off salt and water. So just like that, when metal oxide reacts with acid, it gives off salt and water. Reaction of non-metallic oxide with base. Now when this non-metallic oxides, such as carbon dioxide, when reacts with any of the metal, such as this calcium hydroxide, this is base. When reacts with carbon dioxide, it produces salt and water. So the reaction is also basically the same thing, which means that non-metallic oxides, they are basic in nature. What do all acids and all bases have in common? What is the common thing between all the acids and all bases? Let's learn. Now, the most important and very obvious common similarities between the common properties between the acids and bases is their conduction of electricity. both acids and bases solution, they conduct electricity. That can be explained by the presence of that can be explained due to the presence of free radicals, such as in the case of acids, the hydrogen ion presence of hydrogen ions, and in the case of basic solutions, in the presence of hydroxyl ions. What happens to an acid or a base in a water solution? In a water solution, acids, it results in dilution, and even the bases also, it results in dilution, because of the fact that water lies in between both these acids and bases. So it's like water is the neutral medium for these acids and bases. So when either of the when acids reacts with water, it results in dilution, and similarly when base reacts with water, it results in dilution. Acids base, now these are the reaction. Acids base keeps off the salt and water, so it's just the repetition. So they are, it's very lengthy, but the thing is that they are all repetitions and lots of examples and exaggerations, so we don't need to worry about that. Is the center core is the same thing. How strong are acid and base solutions? How do we understand? How do we know? How do we determine whether that given acidic solution is little acidic or too acidic or too basic? How do we determine the strength? We determine the strength of acid or base solution by using the indicator. We have lots of indicators, and we have the pH scale. We have the pH scale. So lots of markings are there in the pH scale. We will get to learn about that. Now basically this is kind of this is how the markings in the pH scale looks like. pH scale starts from the 0 and 1 2 3 4 progressively to the right up to 14. This is a very basic and common standard form of the pH scale. Now 7 lies in the middle, and 7 indicates that the pH is neither acidic nor basic. So 7 is the number which is like a neutral number. It's like it's a neutral number. So anything less than 7, it will be acidic in nature. Anything more than 7, it will be basic in nature. So this is how we determine the strength of the both acid and bases based on the scale given in this pH scale. Importance of pH in everyday life. Now pH means the strength of whether the solution is acidic or basic. It is very important in our daily life. If it is too acidic, it's not good. If it is too basic, it's not good. So all animals, all life, all living things, they have that certain limit of this acid and basic compounds. If it is too basic, it is harmful. If it is too acidic, then also it is harmful. So our body works within the pH range of 7.0 to 7.5. If the rainwater is less than 5.6, then we call it as acid rain. Now acid rain is very harmful because it damages the vegetation. It's not good for the plant leaves, it spoils the plant life. So that's why it's not good. Acid rain is not good. Now the more air pollution we have, the more likely it will form acid rain. Now what is the pH of the soil in your backyard? This is just a discussion question, which tells us that there is a certain limit for this for the soil to have the pH. If it is too high, if it is too low in number, it's not good for the plant to grow. pH in our digestive system. Now pH in the digestive system, we have acidic, we have a lot of acids in our stomach. But if it is too acidic, then it will result in ulceration, formation of ulceration, irritation and pain, and gastric. So that's not good. In those cases, we use these antacids to neutralize the excess acids that are formed in our stomach. pH change as the cause of tooth decay. Now we have the toothache, tooth decay, lots of problems. That is not because of the microbes eating away our teeth, but because of the acid pH change in our teeth. Now, yeah, it is like the germs eating away our teeth, but it's not really like that. The fact is that in the teeth, the food remains are eaten by the bacteria, and the bacteria produces acids, and this acids is actually the reason of decaying of our teeth. So it's very important to maintain the pH value even in our mouth to protect our teeth from decaying. Self-defense by animals and plants through chemical warfare. Now honeybee stings, lots of bees stings, and most of the bees, they have the poison in the form of these acids, and in some cases they have this basic. So these acids and bases that are formed in the animals, some animals use it as a defense mechanism to protect it from the predators. Yeah. Now this table is giving off the acid and the natural source, such as this acetic acid. We get this acetic acid from the vinegar, citric acid from the orange, tartaric acid from the tamarind, and oxalic acid from tomato, like that. So no, lactic acid from sour milk curd, citric acid lemon, and methanoic acid and stink, and methanoic acid also from the nettle stink. We have another topic that is more about salts. What are salts? We will learn about these salts. Now when we say about the salts, we really mean the salt, the common salt that we eat every day, the table salt. But it's not just that salt. We have so many other salts, such as copper sulfate, sodium nitrate, sodium carbonate, like that. In addition to the well-known sodium chloride that we eat every day. So that's the family. It's like the kitchen salt. Yeah, the family of salts. We have lots of salts, but we don't need to know all about those salts. The few handpicked mentioned salts, that is sodium sulfate, sodium chloride, those things are necessary. pH of salts. Now let's learn about the pH of salts. Now the salts, which is the product of the reaction between the strong salt and the strong base, will be neutral, which means that their result product, the salt which is formed by the reaction of the strong acid and strong base, will give the pH value of 7. So it is 7 means it's neutral. Chemicals from common salt. Now let's learn about the chemicals from the common salt. Common salt, that is our table salt, edible salt, sodium chloride. We get this sodium salt. Common salt is very, very, very useful because of its industrial applications and lots of products that we can obtain from it. Common salt as raw materials for chemicals. we use this common salt to produce baking soda, sodium hydroxide, washing soda, bleaching powder, and many more. We get these substances from the common salt. Sodium hydroxide. When electricity is passed through an aqueous solution of sodium chloride, that is called brine, it decomposes to form sodium hydroxide. That's what it is. We get sodium hydroxide from sodium chloride, which is our common salt. So the reaction is also given in this page, such as this 2 NaCl sodium chloride reacts with water. It gives off the sodium hydroxide and chlorine gas and water hydrogen gas. So now this chlorine gas proves to be very useful because we use this chlorine gas for water purification for our tap water and for our drinking water, which is useful in our kitchen. Bleaching powder is also obtained from our common salt. So the reaction is also given in this way. The bleaching powder, which is the calcium carbonate, calcium chloride, calcium oxychloride, right? That's the bleaching powder. Now bleaching powder is used for bleaching cotton and linen in the textile industry, for bleaching wood pulp in paper industry factories, and for bleaching washcloths in laundry. As an oxidizing agent, bleaching powder, we can use it as an oxidizing agent in many chemical industries, and also to make drinking water free from germs. This is the repetition of the things that we have discussed above. Baking soda, we get this baking soda from that common salt, sodium chloride, and this baking soda we use it for baking our edible our food. Uses of biscuits and all. Uses of baking soda. For making baking powder, which is a mixture of baking soda and a mild edible acids such as tartaric acid. When baking powder is heated or mixed in water, the following reaction takes place, and this is the reaction that gives us the spongy in our bread, and it's very delicious and tasty. Now let's learn about the washing soda. Washing soda to wash our clothes, and that's it. The chemical name of this washing soda has to be sodium carbonate decahydrate. Decahydrate is because of this presence of tan in H2O. So before this H2O, there has to be some tan here like this. So because of this tan, it is giving this decahydrate. Hydrate just because this is water, and in the presence of excessive this hydrogen molecule, we simply called it as decahydrate. Washing soda. Uses of washing soda. Sodium carbonate used in glass, soap and paper industries. Manufacture of sodium compounds such as borax, like that. So many things. Permanent hardness of water. We can when the water is hard, not littering well with the soap, and it makes the washing of clothes difficult, we use this washing soda to soften the hard water. Are the crystals of salts really dry? No, the crystals of salts are not really dry. So we can prove that by following this reaction. Heat a few crystals of copper sulfate, which is salt, okay, in a dry boiling tube, and it results in we will see that there are some droplets of water on sticking at the surface or on the walls of the test tubes, because before we do that it was totally dry, which shows that the salt is not really dry. Plaster of Paris. Let's learn about plaster of Paris. Plaster of Paris. Now this is very, very useful. If your any of your bone gets fractured, the doctor used this plaster for supporting the fractured bones. They will plaster it, and after some time, when your bone is reformed and reorganized and hard enough, they will remove it. So that's how you repair the broken bones, by using this plaster of Paris. So this is at the end. This is really the end of our chapter and of our discussion. So there are lots of questions and answers. So it will be just hovering around the topics that we have discussed just now. So it's very plain and simple. The only thing is the intelligence in all these exercises and solving and reasoning. Little bit of reasoning is required for this chapter to be covered, and that's all. Thank you so much for watching.